Welcome to MMT Chats. This episode is brought to you by ISCAR with new ideas for machining intelligently. Hey MMT followers, Christina Fuges with MoldMaking Technology for another quick MMT Chat. My guests today are both from Grand Rapids, Michigan-based Action Mold and Machining, Additive Manufacturing Manager Greg Nemecek, and Additive Manufacturing Specialist, CMM Technician Zachary Glascock. And Zach is also one of MoldMaking Technology's 2021 30 Under 30 honorees.
Yes.
So make sure you check out MoldMakingTechnology.com. So find out more about him. It was a kind of an exciting background, exciting. You could definitely feel your passion, Zach. So people can read about you and all the other 29 honorees. And we keep getting more in. So I want to encourage everybody out there, continue to send me nominees because we created a separate page on our website to house all this next generation professionals coming in. So yeah, definitely check that out. All right, so Greg and Zach are here to dive a little deeper into a recent conversation we had about their first live additive manufacturing trade event. And they're going to share perspectives on some additive trends and technologies from a seasoned professional person, Greg, and a next generation professional, Zach. So hi, Greg and Zach. All right, so let's start off. Okay. How would you describe, we'll start with Greg, how would you describe the state of the mold making industry's mindset when it comes to metal 3D printing? You know, has anything changed about the conversations you're having lately when it comes to 3D printing and additive manufacturing with your colleagues, with your peers?
Yeah, I would describe it just that way, changing. No. We know that, you know, most mold buyers, at least the people that are holding the purse strings, they look at the cost of tooling. And the rate at which a tool can produce parts is not generally looked at. I mean, they do look at it at the onset, and they figure out where gating needs to be and all of that to try to produce the best parts and get the best cycle time, but they don't really look critically at the cooling side of it. And what I think that's going to change soon. After having a conversation with a gentleman from General Motors, he made it clear that he understands the struggle that we're having with getting the molders to buy the tooling that is conformally cooled. And he you know, his comment was that until the edict comes down from the big three or from the people that are ordering the parts, and they make the claim or have the edict come down that says you're going to use conformal cooling because we want our parts more consistent and we want our parts to be cheaper. And the only way you're going to get there is by running the cycle times faster. So yeah. That's what I see as being the big push right now in the AM tooling. And hopefully, you know, it really begins to come downstream to us.
I think I am actually starting to see that happen, and more people, even though conformal cooling using 3D printing has been around a while, I think it's really starting to pick up in terms of people really applying it. So Zach, how about you? Has the conversation changed in your world about 3D printing's potential within mold making?
I mean, I think Greg and yourself just hit it on the head. Really, I mean, it's starting to pick up. They're starting to realize, but there's still that hesitation of cost, the upfront cost of this tool, of these tooling, because when you design a mold, you design it from your part data, and more than half the time you aren't running simulations on it to see your cycle time, so you can only estimate cost. If you were to run that simulation, you'd see, okay, well, this part is running at a 30-second cycle time, but with the current design. But if we were to integrate the simulation software and also conformal cooling, you can knock X amount of seconds out of your cycle time, and then you can just watch. You can see the data before the tool is even manufactured. You can already see your cost saving comparably between the two.
Yep.
All right. So another big topic is work coming back to the States, right? So reshoring. So I know we talked a little bit about this before. Can either one of you or both of you, can you share how additive manufacturing can play into that, can be part of a solution to bring to bringing tooling more back to the States?
I think, honestly, that's a really, really tough question. Years ago, the U.S. In manufacturing, we always had advantages because we had technology and we had machines that were better than what you would find in the Asian markets. And today, that leading edge has kind of gone away on that side of it. With everything being designed today using computing technology, using softwares like Siemens NX, CATIA, and then you couple that with all the all the machining centers that are now available around the world. We don't have this huge leading edge, but the only way I see it bringing more work back to the U.S. is going to be if people in the U.S. take the technology and start to become really creative in how to produce their parts and produce them more efficiently and more effectively. That's the only way I see it bringing tooling back to the U.S. We really have to be creative in how we use the tooling, because all the stuff is available to everybody.
To everyone.
Yep.
Got it. You agree, Zach?
I totally agree. I mean, the overseas market, they still have the same capabilities that we do, but in some scenarios, they can produce a mold or manufacture something at a little bit less of a cost. That's really hard to beat or compete against. But maybe one mindset that you could have is that if the US starts developing this additive manufacturing technology into their currently manufacturing processes, then we could see let's say, for example, the big three coming in and localizing their manufacturing because of these added capabilities that we have right in-house.
Yeah, I agree with that. All right, so I know you guys both, the show that you went to, the first live event right this year was the AMUG, the users group, which I love that event. It's really, I think, a nice intimate event where there's a lot of networking and learning going on. So can you share a little bit though about people that you met and the sessions that you sat in on? Like, was there a new technology development or enhancement that really intrigued you this year? Greg.
For me, one of the things that I've been keeping an eye on is the folks over at Dendrite. They are, being a designer, I've had to work with software and hardware where things kind of teeter-totter. First, the software was really good, but then the hardware was lacking, and then they would make huge upgrades to hardware, and then it would run really good, and then the software would get more complicated, more lines of code, and then it wouldn't run as fast, and it kind of goes back and forth, right? So the thing that I like that they're doing that I think is rather unique, I'm still waiting to see how it all pans out, is how they're taking processing power from these graphics cards that are they're getting more and more powerful. The graphics cards have more GPUs and they're more processing power than ever before. So they're taking the unused GPUs from a graphics card and they're using that to do computational design computations. And so it's supposed to speed things up tremendously. And what I've seen so far, it is, but there's still a ways to go before they get all of it. They're starting out primarily focused on the additive manufacturing market. That's where they're debuting their capabilities.
Okay.
And but I still think they have a ways to go. We shared some models with them when we were at AMUG and said, here, take this and slice it. And they were able to do it, but it wasn't exactly what we were looking for. But it showed me that they're on the road and they're making strides in that. So I'm kind of keeping an eye on that.
That's exciting. That's an avenue of this technology that really doesn't get talked about. So that's an interesting. Do you know why they are targeting additive manufacturing or 3D printing with this?
I think because it is so new and there's such a need. I mean, Zach will tell you, when you go to slice a project You know, you get a complex file and you go to slice it with Quantum. Quantum's a great product, but we'll sit there and we'll wait a half an hour for it to slice the model. And as a designer, you look at it and you say, I don't have a half hour. I need that thing to slice right now in 30 seconds or 40 seconds so I can look at it and determine, is this going to work? So yeah, that's something that I think is from the software engineer side, they haven't overlooked it, but the industry in general, I think they don't understand the struggle sometimes that designers go through with having to wait for something.
Yeah. All right, Zach, how about you? What did you see or hear or learn about or talk to somebody about at AMUG that, you know, caught your attention?
So I think one of the things that really spoke to me, and especially for this industry in particular, is we saw a few DED, direct energy deposition additive manufacturing processes. One of the cool things that we're trying to develop with our platform is being able to repair tooling with already existing steel. DED uses a process where you take an existing piece of metal and you are able to print on top of it while rotating, changing position. You're just basically building up from that surface. And so with that being said, you can take that and you can do your conformal, but one of the cool things that they are currently doing is they're integrating multiple materials. So they're able to integrate a steel insert, but also have copper impregnated in certain locations. So you get both the wear resistance and strength that you need in certain locations. And then when you get to a hot spot, they can print in a piece of copper to cool that area better.
And that's the same on the same machine, correct?
Yeah, same platform.
Yeah.
So it's very, very cool technology.
All right, so let's go back to design and engineering for AM. Everybody talks about DFAM, right? Design for additive manufacturing. I think it was great that you actually talked about like truly designing for AM. So talk about that. What do you actually mean by truly designing for AM?
So coming from a background that only focused on subtractive, you know, before we had all the additive technology, it can make it a little bit difficult for me. And I'm just being honest, you know, maybe it might be dating me a little bit, but I have to remind myself when I'm going to design something to, you know, that I don't have to build the block first. You know, I have to take the shackles off, so to speak. So I can look at it holistically from an additive manufacturing standpoint and say, you know, where do I want my water? How do I want this thing to mold? And then allow that to free form first, and then go back in afterwards and do the necessary designing to put in your bolts or your retaining lugs or however you're going to hold the insert. Where I think that is going to change in the coming years is going to be through companies like N-Topology and Gen 3D, where they can take forces, loads, and enter all that stuff into the software and give it regions where if you design your water, you'd give it instructions to keep out of these areas because these are already established, and then you let it generate the necessary supports for whatever it is that's going to be printed. We did some work at an Altair event that I went to where they gave us a part and they told us, you know, there's a bolt that goes through here. These are the 4 mounting bolts, and this is where the load is, and this is the direction of the load. And then you entered all that information and you kicked it off, and it just generically builds this crazy shape that is just as strong as it would be if it was a billet, but it's only puts material in where it's needed. So
where you need it. So it's actually this is doing the thinking for you almost, right? It's automating that process.
Yes,
Which happens on the mold making side. I mean, the software has gotten good on that side, so why wouldn't that be applied to additive, you know, when traditional people in the field struggle to switch their mindset. Like, Zach,
Right.
would you agree with that coming into this? I know you have some subtractive experience too. Is it as hard for you to make that shift on the design side?
I would say because of my lack of experience, it's a little bit easier in a way for me to say, oh, well, you can do it like this and do it like this, and it doesn't need to be thought out in a subtractive manner.
Yeah.
I think a great example to kind of get to that point is asking yourself why when you're designing. Why is it a square block? Why is it a straight hole? Why is that hole circular? I mean, with additive manufacturing process, you don't need to be, you're not restrained to
Right.
a drill making a hole or a cutter making a straight face. Your design aspects are almost limitless to certain extents, with limitations of the actual printing that you need to keep in mind. When designing for additive, I mean, you really got to take into consideration your overhangs, surface finish. I mean, really those limiting factors. I mean, but you would kind of take those into consideration while you're designing in a way. So you're working through the steps, you're working through the process.
Right.
I know that Greg, he's mentioned it and taught me this multiple times, but when he goes to design a block or design an insert, he starts from a block and works down in the manner that he would subtractively do it on a machine. So I think that same aspect needs to be applied to the additive process of, okay, so I can have a hole here, but it can't be larger than this because I know there's going to be an overhang arch that won't be able to print. So what do I have to do?
Yep.
Yeah, and you know, you got the other aspects you got to think about, how you're going to hold it when you're going to machine it, how are you going to get the powder out of the internal channels. But yeah, it's a change, that's for sure. And it's good though. Yep.
It is good. All right. So can one of you give me some details about the testing that Action is currently doing with an old additive manufactured insert that was designed with the traditional mindset, right? And then you were designing that same insert, but only with additive in mind. Can you take us through that?
Well, we've got a couple jobs here that were built, and then we went back after the fact, and after we got our printer, we said, you know what, let's design inserts for this for additive. So that's kind of along the lines of what you're saying there, but we haven't specifically built anything traditionally with the intention of going back afterwards and printing an insert and saying, let's do a comparison. The only reason that we're able to do the comparisons that we have been doing is because we already have tooling next door that is ours, that we are at. It's, you know, we have the liberty to do with it what we want, right? So we're taking existing tooling that way, and we are redesigning for additive.
Okay.
That's really where we're at there.
Okay. It would be interesting to get that when you're talking about changing the mindset, like to actually do that, like take that old part and have somebody that doesn't have that traditional mindset and see if they would do it differently with additive, right? That could be interesting. All right. So I know Action Mold, like you've been, since I've met you, you are just constantly working on proving out additive for tooling applications, and then you're way open about sharing what the team learns, and that is commendable because not a lot of people will do that. But you also, I want to give a shout out to you guys because you also have a new patented additive manufacturing product line that we talked about. So why don't you describe what that is? You know, what are the applications, the benefits, limitations? Let's go through that a little bit.
Okay. Basically, it's another method for venting tooling, right? And when you're injection molding anything, you're going to get gases in the part.
Yep,
and
big deal.
And so, you know, if you get enough trapped gas in a region of a part, it will create, like Zach will tell you that the term they use is dieseling, right? So if it gets hot enough and it gets under enough pressure, it'll actually ignite and it'll actually burn the material that you're molding, and over time it'll damage the tool. So We developed a set of parameters and refined the parameters from Renishaw to create a porous material. So when you print it, it's got porosity to it. So you can have an insert that you print, and you can print a section that's somewhat porous where gases can pass through. And as we looked at that, we saw there was an opportunity to take that process and build it into ejector pin tips. What some companies are doing is they're printing the whole pin. You know, they'll print the tip of it porous, and then they'll print the rest of it solid. And as we looked at that, we thought, you know what, there's a better way to do this. And in fact, I had tasked Zach with downloading some models out of our library and building them so we could 3D print the pins and vent them. And he came back a few hours later and he said, I got a better idea. He said, why don't we just print what we need? And when he showed me what he was working on, I said, that's an awesome idea. So what we're doing, and you're going to see this, we're working with DME. It may be coming out in their catalog.
Oh, nice. Okay.
We gotta put everything together with them. So, but we've got this submitted to the patent offices. There's a patent pending on it. We're taking the tip of, basically we're just making a short section, and we're building it in a way that it can be inserted into the end of an ejector pin, and that way you can have any length pin you want and
it's brilliant.
Vent it. Yeah, it's really going to be cool.
And it's funny because what you said, print what you need, that's pretty much the theme of 3D printing, right?
Right.
It's printing what you need, nothing more. So that goes right. That was like what should have been natural, right? It was like, oh, light bulb goes off.
And
that's
the same thing can even happen with hybrid printing. We'll take a piece of P20 or a piece of H13, and we'll put all the traditional machining into that block that can be done. And then where it gets really complex or complicated, we'll just print that region, because you don't need to print the whole block. If it's, you know, if there's ways to machine it faster, go the way that's fastest.
Yes.
But if you're getting into a region where you can't machine something, then we'll print it.
Smart. Zach, do you have anything to add to that, since it was kind of your idea?
I mean, I think one of the main kind of aspects that goes along with this patented product is that it's so easily interchangeable. Let's say, for example, the molding industry is very familiar with a material called porcelax. Some people have different opinions on it. My opinion is that it's okay, but it clogs very easily. So with that being said, this tip is almost like a porcelax, but it has a larger void, a larger spacing between each kind of fused area. And so it's not as easily clogged. But let's say if it ever does happen to get clogged and it can't vent properly, if it's on the end of an ejector pin, all you have to do to exchange it or replace it is, while it's still running in the press, move your ejection forward, unscrew it, pop a new one back in, and you're off and you're back running. So I think that's another key aspect to this interchangeability of these parts.
That's great. All right, last but not least, I know you guys talked about, you made some great connections lately, and especially at AMUG, people that you've met. Can you share any details about any of them? Just to kind of whet our appetites about what additive technology and applications development could be coming from Action Mold outside of this product line. Anything else?
Well, for me personally, I like it when somebody can speak to me and inspire me. And I was at breakfast one morning, and we sat down with an individual who designed a tennis shoe, the sole of a tennis shoe. And he was very critical of how previous designs had been made. And he was saying, you're using the same structures to support the sole of the shoe when it should the bottom of your foot changes constantly, right? So
Yes.
there's not just a flat surface there, it's contoured. So wherever when you're stepping, you're going to create pressures, different amounts of load on different points on your foot. So he developed a way to for his support structures to change in diameter and height and width as it goes across where the load is being applied.
Wow.
And that's truly designing for additive.
Yes.
Where you're changing on the fly, so to speak. And when I was explaining to him some of the things we're doing with tooling, he was very, very polite. He said, but you're still not designing for additive. You have to change the way you think. And as we continued our conversation, I realized he was right. Even though he's looking at it from a different perspective, which is sometimes what we need. He was looking at it from a different perspective. He made me see that I do have to go back and rethink yet again how I design for additive. So those are the kind of things that excite me. We connected with some guys from the Plastech group, and they do a lot of small container molding. And just looking at some of the stuff that they're doing, we sat and talked with them one night, and we came up with several ideas for conformal cooling some of their stuff, and you knock a couple seconds off their cycle time. That'd be huge for them.
Exactly.
But again, we got to go back and look at the whole process again, and design truly for additive, I guess is what I'm saying.
Well, it's exciting to just rethink things, right? And like you're saying, to hear something about a shoe or a sneaker, I mean, that's like life in general, to get that other perspective, because your initial reaction is, well, that's not what we do. That's not going to apply to us. And if you stop and think about it, you can always learn or apply something from some other way of doing something. So I commend you for that, because that's the only way you're going to move on with new technology. If you said that with every technology, you would never change. You wouldn't be doing anything. So Zach, how about you?
I think one thing that could be in the works and in process is being able to integrate sensing devices inside of your tooling, using the additive manufacturing process. I mean, while it's printing, you build up to a certain area, and then you are able to, in some cases, to place a sensor and then continue your print, encapsulating it, but you still have that sensor in there that can be used inside the tooling to extract any data that you need.
Yeah, that goes right along with Industry 4.0, right? That hot topic. And now I've been hearing a lot about that. I think I talked to Mark from Fabrasonic, who was talking with you guys about doing that. I mean, that's a great application for tooling, because that's where the industry's headed, with or without additive. You're talking about sensors and collecting information, so that's great. All right. Well, on that note, I want to thank you both again for your time and for checking in. I think you guys are so proactive with this technology development that I want to check in with you every so often if you're still willing to share. So again, thank you. And to everybody watching, remember, for everything mold making, visit moldmakingtechnology.com. Stay safe and healthy, and more importantly, stay informed and stay inspired.